So today we'll discuss about the state file again. Already we understood what is the state file is. It's going to be map whatever the actual resources we have in the like Azure or AWS, where we have the infrastructure managed by Terraform. Okay, and the configuration files. Both should be in the sync. If there is any difference between them, that is called as the drift. Okay, so that means if any of the resources have been drifted, that meaning is that actual resource or configuration resource have been modified little bit, and that's may cause that resource has been drifted. That resource has been drifted. Okay, so if you don't have the state file, what is the problem is going to happen is for the next apply each and every time. Okay, so Terraform is going to create a duplicate resource. Okay, so Terraform is going to create a duplicate resource. If I don't have the state file, what is Terraform will assume is the second time if I do the Terraform apply, if that state file doesn't have that resource, then Terraform will assume that resource is not there. Then it's going to provision the resource. In order to avoid these kind of situations, what we are doing, in order to avoid these kind of situations, what we are doing,
State file
yeah, we are going
creation.
to maintain the state file. Okay, so then when we do the next time apply also, if already that resource is existing in the state file, Terraform will assume that resource is existing. It won't provision that resource. Otherwise, what is going to happen? Again, it's going to create a duplicate kind of resource is getting created. Okay, so in order to track these kind of things and dependencies, all the resource IDs also we are going to store. Okay, then if any changes need to be performed, 90% is not recommended to do directly in the Terraform state file. Okay, so from where we need to perform those changes? From where we need to perform those changes? Those changes need to be performed from the configuration file, then state file, then actual resource. But reverse is not at all recommended. What is the reverse order? Say someone did the changes in the GUI, then you can modify it from the configuration files that. But directly changing is not at all recommended. Okay. So then if someone asks about Terraform state file, what you will tell? If someone asks about the state file, then what you will tell? So state file is is going to store whatever the resources we have provisioned through Terraform. Those resources are getting stored. Okay, it's going to map the resources defined in our Terraform configuration onto the real world resources. And what is the name of the state file? What is the name of the state file? The terraform.tfstate is our state file name. Terraform.tfstate is our state file name. Okay, so by default, where the Terraform state file is going to store? By default, where the Terraform state file is going to store? By default, it's going to store locally. But what is the problem with this? Here local state file is not a not ideal solution for the team collaboration or production environments. Okay, so for that purpose, we are going to store it in. For that purpose, we are going to store it in the remote backend. In Azure wise, we are going to use in the remote backend, we are going to use. And what is the meaning of locking is, if someone says, suppose we have enabled with the local state file, anyhow locking not much usage, but in the remote backend, in the multi-team environment, okay, so one team member is using Terraform configurations, like he's doing some changes, maybe he's applying some changes. Okay, so then modifying the state file simultaneously, which may lead for corruption or conflicts of the resources. In order to avoid that one, if the state file is in the use, okay, in the remote backend, we are going to lock it. Okay, so then in locking depends upon the backend. I'll tell one example. In AWS, we don't get locking by default. Okay, so in AWS by default we don't get. In Azure, what is the remote backend we are using? What is the remote backend we are using in Azure?
Azure ARM template, right?
No. The
Blob,
remote backend.
blob storage.
Yeah, Azure Blob storage we are using for our remote backend. Okay, if I use the say in the same way in AWS, we are using S3 buckets. In AWS, we are using S3 buckets. Okay, by default, if you use the S3 buckets, we don't get locking. For locking, we are using DynamoDB. Okay, so we are creating one serverless kind of database, DynamoDB, for the whether that statefile is locked or not. But in Azure, you don't need to do anything because your Azure Blob storage itself by default supporting locking also. So what is your understanding of remote backend? Instead of keeping the state file locally, we are keeping in Azure Blob storage. And what is your understanding of locking? What is your understanding of locking? So if any of the user or if any of the team member is using the state file, that should be locked. Okay. So by default, in the Azure RM, like if you use the Azure Blob storage, our state file is supporting locking also. But in AWS for remote backend, what we are using? For the remote backend, what we are using?
S3 bucket.
S3 bucket. But by default, we don't get automatic locking. For that, what we need to do?
Using DynamoDB.
Yeah. So we need to create one more DynamoDB table. In that, it's going to store whether that like state file is locked or not. Whether that is a state file is lock or not, we need to track it. And say suppose here we have one more use case we would be getting. Say we are trying to apply our infrastructure and it's remote backend we have. Okay, so then like Terraform keep on staying. Okay, uh, like it's locked itself. So that means I ask for everyone. No team member is using that still. Okay, still what is the error I'm getting? The state file has been locked. You can't use it. Okay, so in that scenario, what we need to do is, okay, we may need to, so we may need to use unlock. We need to use. Okay, so when in which scenario you are going to use force unlock? In which scenario you are going to use force unlock? Okay, so force unlock, which command you need to use is, so try to understand here, terraform force hyphen unlock. So when you do the terraform apply or plan, you'll get one lock ID. Okay, so with that lock ID, that state file has been locked now. But in which scenario you are going to use that force unlock? In which scenario you are going to use? So everyone are telling they're not using state file. Somehow it has been locked. Then you are using force hyphen unlock. And here in which scenario you are going to use lock hyphen flag is false is. If you don't want locking by default, then you need to use that, but that is not at all recommended. But that is not at all because that may lead for like conflicts in the state file. That may lead for the conflicts in the state file. I hope you understood, right? Okay, so then what is the advantage of the state file is if I implement the state file, okay, only one process can write into the state file at a time that stops the tampering or like which is going to affect the state file. changes, multiple changes, not recommended to modify. Okay. Then again, remote backend, like a remote backend store the state file in a centralized and remote location. In our examples, we are using Azure Blob storage. Okay, so we'll have a team collaboration, security, state locking, and versioning. So these are the advantages we are going to get it through by using the remote backend. So these are the advantages. With the local, we don't get that. Okay, so that is advantage we are going to use. Okay, so then we are using, say here, we are going to use, already we discussed this. We are creating a resource group and storage account. Okay, so once we create the storage account, blob container we are using. Okay, so then storage access key. Then from this, we are going to use our backend. So in the backend, we are giving the resource group name, storage account name, container name, and the key name we can keep whatever the name. By default, we are keeping terraform.tfstate. This either in the provider block you can keep, or you can create one more block it as. So what you can keep one more block is like a terraform sorry, backend.tf file. You can keep it. In that you are going to store that one. In that you are going to store. Okay. Then like definitely we need to reinitialize if we change the backend. Okay, so if we are using local state file and now we are going to implement a backend, definitely we need to do the Terraform need to do, because that local state file need to be moved to this, and simultaneously if a other users uses that also, it throws an error. Okay, so after that like state file has been removed, then only we are going to use. Okay, say before doing force unlock. Okay, so definitely we need to make sure no one is using that state file. No one is using that state file. We need to confirm. Okay. Yeah, and definitely we need to give the permissions like maybe and encryptions, all those also we need to perform, because what is the challenge here in the state file we are getting is, if any of the resource like we have the passwords or those kind of sensitive details if we have, okay, so maybe Azure AVD itself, we have our passwords, all those have been stored in the state file. What is the problem? What is the problem there? Everyone can see from the state file in the multi developer environment. Everyone can see the state file. Everyone can see. What is the advantage, disadvantage with that? Everyone will get the passwords. In order to avoid this one, okay, so we need to encrypt also our state files. And definitely backups also is mandatory for the state file, because sometimes if any of the state file have been deleted, at least with the versioning or backup, okay, better to restore at least the previous one. Small changes we can do the Terraform refresh and those changes will come, but at least have a proper backup also. Have a proper backup also for the Terraform resources. Okay, so that's the reason. Like what we need to enable is the state file may contain the sensitive data, it may have the passwords and keys. Definitely, we need to use the encryption at rest. So, what is that meaning is it's going to be encrypted. Even if someone want to access that, we shouldn't give, because it's the state file may contains the sensitive data, password kind of details it's going to store. Okay, so then here we have one more important point is there. Import an existing Azure VM into Terraform. Okay, so we don't know Terraform Azure. Previously, without knowing to Terraform itself from the Azure portal or from CLI, PowerShell or ARM templates, we already created a lot of resources. But now onwards, we need to use, now from today onwards, we want to use the Terraform itself. That means already some resources have been created already by GUI, that means Azure portal, Azure PowerShell, or maybe ARM templates. But from today onwards, those resources also we need to manage from, those resources we need to manage from the state file itself, we need to, sorry, from the Terraform wise itself, we need to manage. In this use case, what we need to do is, we need to import those resources into our state file. That resource is already existing. Where that resource is existing?
In Azure.
In Azure, that resource. All these days, from the configuration file, it's going to create in the Azure and writes in the state file also. But now what we need to do is, that resource is already existing in the Terraform, in the Azure. But now that resource, we need to manage it from the Terraform wise. Then in that use case, what we need to do is, we need to import that resource. So we need to import that resource. Okay. So for that, Terraform has been given one command called as terraform import. Okay. So now here we'll import one resource. Okay. So terraform import Azure RM underscore Linux underscore virtual mission dot example. Okay. Slash that ID. Okay. That means this is the VM ID, the complete VM ID we are getting. Okay. So you can go to the portal or from the CLI, Azure VM show, that resource group. Okay. So that if you run this, it is going to display you the, or from the portal also you can get that. Okay. That ID, because how we got the ID? Because that resource is already existing. Okay. Then here, what is the name we are giving for that VM? What is the name we are giving to that VM? Can you tell me? What is the name we are giving to that VM? From the Terraform wise, we are giving a name to that virtual mission. What is the name we are giving from this perspective? What is the name we are giving? The example is the name we have given. Okay. So previously we don't have that example. Okay. But what we are giving here, what we are giving? Example is the name, but whatever the name you want, you so this will import to that resource to where it is importing that resource. To where it is importing that resource.
So my VM.
To the state file, it is going to import that resource. Okay, already we have that resource in the Azure portal, but now that will import all the resource details into state file. Okay, so then in which location that resource configurations are missing? In our TF file, that resource is missing. In the TF file, that resource is missing. Okay, so once you got that resource, okay, so this block you need to keep in your, which file you need to keep this? Which file you need to keep in this file? That file you need to keep in the
terraform.tf.
Yeah, in the main.tf you are going to keep that. Okay, how we will get that? Say that example we gave the name, right, while importing. Here that resource name also you are going to keep the example, and this is the name from where you are getting this name. This is from the portal we are getting. All these details you can see from where you can see. from your Terraform, that resource, you can see that. Okay, from that resource, you can see that resource, and from that you can provide all these details. Say suppose already when resource is existing, then what we need to do? If already the resource is existing, then what we need to do? First, you need to import that resource. So that import will bring to state file. Once you build that resource, after that, what you need to do? After that, what you need to do? In the main.tf also, that resource block, you need to keep it. Okay, if you don't keep it in the main.tf, what is going to happen is Terraform will destroy that resource because that resource is not there in our main.tf. Okay, so that is the reason. Definitely, you need to keep that resource in the main.tf also. You are going to keep that resource. Okay, all these details like East US, size is standard, B2S, admin user is Azure user. All these details, how you are getting? All these details, how you are getting? From the Terraform, like while importing, all those details will come to. All those details will come to. All those details will come to your state file, right? From that you can get those details by seeing Terraform show. Okay, you can see all those details. From that you can manage it. Okay, so from that we can manage. Okay. Then after that, just check that plan also. So now here that resources, suppose if you have any dependencies resources also, those also we may need to import those resources also. Network interfaces, disk, those details also we may need to retrieve. So suppose if it is a VNet, that VNet may have like subnets or in network security groups. So those also we may need to import those resources. Okay, so those also we need to import and we need to bring it. So this I'll show practically because you may have some 40 to 50 resources also. Those all these days we have managed through portal, but now from now onwards, what we need to do? From now we need to do through GUI. You need to manage through GUI. You need to manage in that scenario. So you need to go for importing the resource. Importing the resource you need to perform. Okay. Say already terraform.tfstate, in which syntax it is going to store. In which syntax it is going to store is terraform.tf. Okay. It's going to store in the JSON format. Okay. State file is in the JSON format. Okay. .tf files uses which scripting? .tf files are using which scripting? It uses HCL. Okay. Say HCL stands for HashiCorp Configuration Language. Okay. HCL stands for HashiCorp Configuration Language. Okay. So from that HCL, we are going to use it. Okay, so one challenge as of now is the state file stores the sensitive details. Okay, but definitely we need to encrypt that, and how we'll maintain the sensitive details also we'll discuss. Then remote state file, already we try to keep one remote state file also. Then tomorrow, like we'll see that what are the issues you are getting with the remote state file also. I'll try to resolve that one. Okay. So definitely we need to secure that also, how to manage the sensitive details also, because in ABD also, if you are using in the production, we'll have that passwords, all those. Okay. So then here we have one more, like we have the variables. Yesterday we declared the variables, like those are called as input variables. Okay. And in the variable by default, what we have is in the variable, while declaring the variable, we gave one default value. Okay, if I don't give any value to that, this value it will take up. But when I'm doing the Terraform apply, okay, I gave one value for that by using one -var. Okay, so what is this meaning is I can use either default value, or at the time of apply, I can use the -var also, but the importance would be given to environment variables. Okay, so now in this, like what is our variable name is, already we declared one variable name. Okay, so that means that variable name is region. Okay, but while exporting this as an environment variable, okay, we are adding one prefix. What is the prefix we are adding to the variable name? What is the prefix we are adding here? tf_var, and the region is our variable name. Okay, so then assume in my variables.tf, my variable is like this. Here we have that variable. Okay, then in this scenario, if I want to export that as an environment variable, then how to use that? Export. What is the prefix I need to use? tf_var resource_group. Resource_group. Okay. So if I declare this as an environment variable, so this is having higher precedence. Even in this variable, I given one default value. Okay, I given one default value. I have like a type, all those I have specified, but it will take the precedence to environment variable. That means if I export this value through environment variable, that is having the highest priority. Or I can pass it, yesterday we pass it through -var also. That means Terraform applies. I use both -var also, default also, and I have exported that also as environment variable. Then which will take the precedence? Which will take the precedence? I pass the multiple things, then which will take the precedence? So that will take the precedence to environment variables itself will take the precedence. If you have passed through var file and default value, to which it will take the precedence?
Var file only.
var file, it will take the precedence. Like this here, And we have one more file, one more option is there, that is called as var_file. In the real time, we are going to use like this itself, because I want to pass different values for same Terraform file main.tf, but for dev I have different settings, for QA I have different settings, for production I have different settings. Then I need to create 3 files. Okay, what is the extension of those files is tfvars. What is the extension of that files? tfvars we are going to use. So with this, what is going to happen is, for the 3 different environments, I'm going to use 3 different files I'm going to maintain. Okay, so for dev 1 file, for QA 1 file, for production 1 file. So that is the meaning of reusability. And in order to maintain the different state files, what we are going to manage? In order to maintain the different state files, what we are going to use? In the different state files, if you want to maintain, then I need to use Terraform workspace. Okay, so that means assume if you want to work on 3 environments, my main.tf, all the tf files would be the same, but I'm going to declare the different variables. Then I'm going to declare dev.tfvars, qa.tfvars, production.tfvars. I'm going to declare 3 different values I'm going to create. And when I'm working with the dev environment, I'll use dev workspace. If I'm using QA environment, I'll use the QA workspace. Means same scripts, but for 3 different environments, creating 3 different configuration files doesn't make sense. Okay, so how we are enhancing the reusability is by adding the variables and passing those values through the different var files. And what would be the extension of those var files? What is the extension of those var files?
tf.var.
Yeah, tf.tfvars. .tfvars we are going to use, and from that we are going to manage. What is the advantage with that? For the different environments, you no need to manage different settings, you no need to manage. And why we are using the different workspaces? Why you are using
For
the workspace?
testing. For testing.
No. For the different environments, we need to maintain the different state files, different output values. Okay. So because if already the resource name is already existing for dev, for production, what is the problem we'll get is that that won't create in the production. But that state file is need to be different. This state file need to be different. Then we are going to use 3 different workspaces we are going to use. 3 different workspace we are going to use. Okay, so that is the advantage of using the workspaces we are going to use. But here, for the different environments, what we are going to use is like terraform.tf var file we are going to use. Okay, by default, we'll have terraform.tf var, but in our environment, you can tell you have production.tf vars, qa.tf vars, or staging.tf vars. Like this, we are going to manage. Okay, so now here we have declared one variable. Okay, and what is the default value we have given? Central US. But what is this we are going to declare is, I'm going to keep terraform.tfvars. Okay, so then in my terraform.tfvars, what I'm using is region equal to East US. Okay, so then I'll create, try to understand here one file. I'll create qa.tfvars. In this VM name, I'm using this. Okay, if you want to change the region also, I can change dev.tfvars. In this, okay, Say in the default, what is the name we have for the VM name? What is the default we have? Default hyphen VM. Okay. So then when I do in the apply this one, okay. When I do the apply, what is the command I need to use is, yeah. So this, like this, I need to use. I shouldn't use the var. What I need to use? Terraform apply hyphen var hyphen file. Okay. That file is prod.tfvars. If you are using for dev environment, then you need to use dev.tfvars. Okay. So if you are working with the QA environment, QA.tfvars. But in this problem, what is the problem we'll get is, like state file would be different for 3 environments and output values also should be different for 3 environments. For that, what you are going to use? For that, what we need to use? So you need to use the different workspaces we need to work. Different workspaces we need to use it. Okay. So these all I'll show in the next session. Hands-on, I'll show that. Okay. So in the production, recommended to use instead of environment variables also, better to use the var file. Okay. If any settings also need to be modified, in which location you are going to change it? So I'll tell one example. Say suppose you want to create a session host. For production, I want to create 10 session hosts. But QA dev, I want to create only 2 itself. Okay. Those you can modify. In which file you can modify those? In which file you are going to modify that?
Production only.
Yeah, in that tf.production.tfvar file, you are going to modify that. Production.tfvars, you can modify. That is the main advantage of
Terraform
using the
variables.
tfvar file we are going to use instead of using from the command line, because we may have a lot of variables. All we are keeping in one file itself. Okay, whatever the variables we have. If I don't declare those values in this, then it may be taken from the CLI or from the default values. From that, it is going to consider. Okay, so tomorrow I'll show these all practically.
Sorry, yesterday you said using commandlet variables only we can.
No, that is we have lot of, if it is one variable is there, one hyphen var you can use.
Okay.
If you have 30 to 40 variables, giving all that from the command line is not a best practice. And if you want to use this from the CI/CD pipelines also, better to keep in the file itself always.
Variable files.
Yeah, variable files. There itself we will modify. In the real time, you don't do much changes. What are the changes you want to keep? Those all will declare in the tfvar file. From that itself is going to set up everything.
Okay.
So that's that kind of automation we need to give to the client also.
Okay, got it, sir.
Okay. So these all we'll see in the tomorrow session. Okay.